Can you remember the carbon dioxide transport, chloride shift, reverse chloride shift, and Haldane effect in less than 5 minutes? Most MBBS students mix these concepts during university exams. But today I will show you one simple flowchart, one memory trick, and one comparison table that will help you recall the entire chapter instantly. And don't skip the last slide because 30-second final checklist that you can revise just before entering the examination hall. So let's start. This single flowchart summarizes the entire chapter. Carbon dioxide is produced by the tissue, is transported to the lungs mainly in three forms. First form is dissolved form 7%. In this 0.3 ml per 100 ml blood of carbon dioxide is transported and it determines the PCO2. Second is carbamino compound about 23%. Here carbon dioxide bond loosely with the amino group of hemoglobin and form carbamino hemoglobin. And third form is bicarbonate form about 70%. This happens entirely inside the red blood cells. So remember, dissolved form 7%, carbamino 23 and bicarbonate 70%. To memorize this, you can remember this BCD rule. Bicarbonate 70, carbamino 23 and dissolved 7%. Now we will understand why bicarbonate transport is the major pathway. This is the most important mechanism in the entire topic. Inside the red blood cells, carbon dioxide enters rapidly. The enzyme carbonic anhydrase converts carbon dioxide and water into carbonic acid. And this carbonic acid immediately dissociates into hydrogen ions and bicarbonate ions. Hydrogen ions are buffered by deoxygenated hemoglobin. Meanwhile, the bicarbonate ions leave the RBC and enter the plasma. This entire process explains why 70% of carbon dioxide travels as bicarbonate. Remember, carbon dioxide diffuses 20 times faster than oxygen due to the high solubility. It only needs tiny pressure gradient to move. So, carbon dioxide enters, carbonic anhydrase act, and bicarbonate leaves. That's all you need to remember. Now comes the favorite university question, chloride shift, also called as Hamburger phenomenon. When bicarbonate moves out of the RBCs into the plasma, inside the RBCs become less negatively charged. So, as to maintain electrical neutrality, chloride diffuses in from the plasma to replace most of the bicarbonate. This is called as chloride shift or Hamburger phenomenon. So remember one simple rule, bicarbonate out, chloride in. So whenever you come across Hamburger phenomenon, immediately think of bicarbonate exit and chloride going inside. The mediator is band 3 protein. What are the consequences of this? The first consequences is more ion inside, so osmotic pressure rises, water is osmotically pulled into the cell and venous RBCs become swell and the PCV increases by 3%. So the venous RBCs become more fragile as compared to the arterial RBCs. Let's make the Haldane effect extremely easy. Remember this memory trick. Haldane is for alveoli. It is defined as oxidation of blood displaces carbon dioxide from hemoglobin. Let's see. In the lungs, when there is a high oxygen, oxygen binds with hemoglobin and this reduces hemoglobin ability to carry carbon dioxide. So carbon dioxide is kicked out and released and exhaled. So that is the curve shift to right. Whereas in tissue, oxygen leaves the hemoglobin. Now deoxygenated hemoglobin carries more carbon dioxide. That is the curve shift to left. The physiological significance is that Haldane effect strictly doubles the amount of carbon dioxide released in the lungs. So remember, lungs, oxygen in, carbon dioxide out. Tissue, oxygen out, carbon dioxide in. That's the Haldane effect. In the lungs, everything happens in reverse. When venous blood reaches the pulmonary capillaries, oxygen floods in and forms oxyhemoglobin. This oxyhemoglobin releases carbamino carbon dioxide and yield H plus ions. Here, the bicarbonate is pulled back into the RBCs from plasma and the chloride moves out to the plasma to balance the electrical charge. The carbonic anhydrase converts bicarbonate back into the carbon dioxide and finally the carbon dioxide diffuses into the alveoli and is exhaled. So, the rule becomes bicarbonate in and chloride out. If you remember these two opposite movements, you will never confuse chloride shift and reverse chloride shift. This comparison table is probably the highest yield slide. Instead of memorizing separate fact, compare the two locations. Starting with the blood transition. In the tissue, arterial become venous, whereas in the lungs, venous become arterial. Oxygen status in the tissues, PO2 drops, whereas in the lungs, PO2 rises. Shift phenomenon. Tissue shows chloride shift, whereas lung shows reverse chloride shift. Ionic movement. In the tissue, chloride in, bicarbonate out. In the lungs, chloride out, bicarbonate in. RBC size. In the tissue, RBC swells up, that is the PCV rises by 3%, whereas in the lungs, RBC shrink back to normal. Blood pH drops by 0.4 because more acidic in the tissue. In the lungs, normalizes back to 7.4. And lastly, the carbon dioxide action. In the tissue, loading occurs, that is the curve shift to left, whereas in the lungs, unloading, that is the curve shift to right. Think of it as a two opposite processes happening in opposite organs. Now let's revise the Viva points. The carbon dioxide dissociation curve is almost linear. The venous blood carries more carbon dioxide than the arterial blood. The respiratory quotient is approximately 0.8. And remember, carbon dioxide is nearly 20 times more soluble than oxygen, so it diffuses very easily. These are the common Viva and MCQ questions, so don't skip them. This is your 30-second exam revision page. Remember, total carbon dioxide transport is 200 ml per minute. Net transport is about 4 ml per 100 ml of blood. The BCD rule, that is, there are three types of transport: bicarbonate 70%, carbamino 23%, and dissolved 7%. The key enzyme is carbonic anhydrase. The key protein is band 3 protein, which mediate rapid chloride shift. Hamburger phenomenon. Here the chloride rushes in to RBCs at tissue to replace the bicarbonate and causing RBCs to swell. That is, the PCV increases by 3%. Haldane effect. Oxygen acts as an acid in the lungs to drive out carbon dioxide. That is shift to right. And respiratory quotient is 0.8. If you can recall all these points, you are fully prepared to answer 10 marks university question and most Viva questions on carbon dioxide transport. If this flowchart helped you remember the entire topic in just few minutes, make sure to save this video for your last day revision. If you are preparing for first MBBS physiology exams, subscribe to PhysioWithNeo, where every topic is explained in 3 formats: complete university answer, 5 minutes rapid revision, and memory tricks with handwritten flowcharts. Comment below carbon dioxide mastered if you can now explain the chloride shift and Haldane effect without looking at your notes.